Welcome back. This is Mr. Greenstein's Geometry, and we're talking about Chapter 10. Section 2 is finding arc measures. So we just talked about lines and segments that intersect circles. Now we're going to talk about the arcs that make up a circle. So let's learn some vocabulary. First of all, the central angle. So the central angle is this angle here, where the sides of the angle are radii. So the vertex is the center of the angle, the center of the circle, and then it meets two radii on the circle. So this is the central angle. An arc is an unbroken part of the circle. So here from A to B is unbroken, so that is considered an arc. The minor arc is an arc whose measure is less than 180 degrees, obviously greater than 0, but less than 180. So if I talk about arc AB, I'm talking about this arc here, not the arc that goes all the way around. That's considered the minor arc, and that's usually what we're talking about when we talk about arcs. Now, if I want to talk about the major arc, then I have to specify a point in the center, which I'll use C. So A to C to B is a major arc, and major arcs are always greater than 180 degrees. A semicircle is an arc whose measure is exactly 180 degrees. The central angle and the minor arc angle. So the central angle and the minor arc angle are always equal. So if I want to talk about the arc angle, I am talking about 59 degrees because it's equal to the central angle. Now let's use this as an example here. This diagram, I have Kn is a diameter and Jm is a diameter. Now I'll solve for J to K to L. Well, that's not hard because Jm, being a diameter, we know is 180 degrees. And we just subtract out that 40 to get our answer for this arc. If I want from L to J to N, then I just subtract out these two parts here out of 360 degrees and to get this solution. On this problem, I have a diameter from A to C. It goes through the center O. And you'll see here that angle A is 35 degrees. So here's my angle A, 35 degrees. There's something special about this triangle. This triangle has a radius here and a radius here. Therefore, two sides are the same length, and that forms Mr. Greenstein's favorite triangle, the isosceles triangle. So if angle A is 35, then B also must be 35. And then we can solve for this angle here in this triangle. Also notice that from A to C, since that's a diameter and a straight line, if I know what this angle is, then I can calculate this angle because it's supplementary to this angle. So you can figure out what that angle is, and you should be able to figure out the rest of this problem. You can work on that right now. Now let's talk about a postulate, the arc addition postulate. It just says that the measure of an arc formed by adjacent arcs, so AB and BC are adjacent at the point B, that the sum is equal to, the sum of the parts is equal to the whole. This is just like the angle addition postulate or the segment addition postulate. So here, if I want to find AC, I'm going to go from here to here. I just add these two angles together. If I want to find ACD, it goes from here to here to here. I add four numbers together, four angles together to get that. And ADC, A to D to C, then I add these three angles together. EBD is E to B all the way around to D. If I keep on going all the way back to E, that would be 360 degrees. So this is 61 degrees less than 360 degrees, and that's how I would calculate EBD. You can calculate that on your own. Here are a couple theorems. The congruent circles theorem. So this just says that two circles are congruent if and only if they have the same radius. So if I have two circles that have the same radius, then I know they're congruent. And if I know that two circles are congruent, then I know they have the same radius. We also have the congruent central angles theorem. In the same circle, two minor arcs are congruent if and only if their corresponding central angles are congruent. So if the central angle here and the central angle here is congruent, then I know this arc and this arc are going to be congruent to each other. Likewise, if I know that this arc and this arc are congruent arcs, then I know their central angles are also congruent. And then we have the similar circles theorem, and that just says that all circles are going to be similar. And finally, these three problems. Are the red arcs congruent, and why or why not? So here you can see this is 80 degrees and 80 degrees, and there's a theorem about congruent central angles. So you use that to either prove this or not prove this. On B, we have an arc here and an arc here, two different circles, but they're concentric circles because they have the same center, and the central angle is the same. So then you can use a theorem to either prove that these are congruent or not. And then finally, I have two circles down here that have the same radius, so they must be congruent. And then I have 95 degrees here, 95 degrees here. You can either prove or not prove that the arcs are also congruent. And with that, we end another session, and we will talk about more of this in class the next day.